Voltage drop testing will show us the difference in pressure between 2 points, which is voltage is pressure. Difference in pressure between the 2 points. Now there's a couple things we need here. We're going to have it charging, and there's going to have to be resistance for any of that to show up. Now the vehicle, all vehicles have natural resistance, so you will see a difference in the 2 voltage readings with current flowing. So a couple things we got to do. We got to start the vehicle up. Here's the condition: start the vehicle up, turn on a bunch of loads, leave the windshield wipers off so we don't scratch the glass, and turn on a bunch of loads so we got current flowing now. Get it off of idle, rev it up, 1800 RPM, around there. So we're off idle, current flowing. We go to the alternator, turn our DVOM to DC volts, take the red lead to the B+ stud, and the ground to the case of the alternator. Take that reading. Go out to the battery. If it's a side post, move the little rubber out of the way and push it down onto the lead, because we want to touch the actual battery, middle of the post or on the post on the side post. Don't touch the studs. You want to get down into the lead. Take that reading. Because if the issue occurs right here where the connection is, we won't see it if we just touch the top of the studs on the side post or if we touch the battery cable itself. So once we got those 2 readings, we compare them, and they should be within 1/2 volt. It's like an acceptable reading, so we're good to go. Our main cables are good. We got current flowing, and it checks out all right. But what if that reading was like this? We got it off idle, current flowing, we got 14.8 at the battery, we only got 14.8 at the alternator, we only got 14 at the battery. We lost 0.8 volts somewhere. So now we got to find out which side it's on. The way we do that, same thing, DC volts on our meter, off idle, current flowing. We go from negative post of the battery to the negative of the alternator. In some cases it might be an external wire, but we want to go to the ground of the alternator, and we want to look at that reading. In this case it was 1/2 volt. Then we go to the positive to positive. In this case it's 0.3. Now 0.3 is still kind of high, but if you look at this, we got a bad problem with the ground. So we would want to repair our ground circuit. But at the same time, when you look at the positive circuit, again, that's pretty high, because 0.4 on either side is pretty much where anything over that is too much. So 0.3 is getting there. And you'll see that when you guys go to practice this. If you go back to your shop and do a practice test on this, you'll see that the numbers are very low. It'll be 0.0 something. But if it's completely 0, then you've got an open circuit or you don't have current flowing. So keep in mind where the ground path is, like I said a second ago. Some of them have an external ground, and some of them you ground straight to the case. 1527, high parasitic load detected. This is where the PCM goes to sleep, knows what the battery state of charge is, calculates what it should be when it wakes up, and realizes it's down way too low. So it says, hey, something's staying on, so it kicks this code on. Now keep in mind, when you do any parasitic load testing, if you're going to go in there, I've seen people do this where they put the amp clamp on the cable and they start pulling fuses and see when it drops back down. I've got a way that you can do this without deactivating any systems or opening up any circuits or anything like that I'll talk to you about. What do we need to get voltage drop? Voltage drop, we can use this for testing for parasitic load, because what we can do is we turn our DVOM to millivolts, so it picks up a really, really low reading, and we need a couple things. We need current flow and we need resistance for any voltage drop to show up. Well, a fuse has natural resistance. That's why it pops before the wire burns. So we've already got our resistance. What do we not want in the first place with parasitic load, parasitic drain? We don't want current flow. So we can find it by simply turning our DVOM to millivolts and going across both prongs on the fuse. If we get a reading, there's current flowing through there. Because the resistance there, now we got current, it's going to show up on millivolts. So we want to do this on all your non-essential circuits. Go through them all, and if anything shows up, you know that's the offending circuit. If you go past the locks and everything checks out, relock the doors later and check it. And when I say later, you want to go and latch the doors or clip the actual light switch down, whatever you need to do, and leave that car sit for about an hour to an hour and a half, depending on how long it takes for each vehicle specification to turn everything completely off. The BCMs and PCMs have to go completely to sleep before you go doing your testing. But once they're asleep, you do those non-essentials. Then, if everything checks out, go to BCM, PCM, navigation, and radio, and write those numbers down. You can go online. Several people have charts for these, but you can go online and convert those millivolts to milliamps. So you go on a volt drop fuse chart and hit images, and one will pull up. You can convert it and then compare that to manufacturer specification for that circuit. So if you got 7 millivolts for your radio and you take your amperage reading that you got from doing the test I told you, you convert it and it says 7, you're good to go. In most cases, you're not going to have to do that though. And what I mean by that is you'll go through all the non-essentials. If all those check out, you'll go to radio, you'll go to Navi, then you go to a BCM and boom, you'll see it spike off the chart. You'll be like, it'll be pretty obvious which one's doing it. Example, I had a BMW that the BCM wasn't going to sleep, so it was still sending out feelers. 100 milliamps is what it was pulling down. It was draining the car. So we're going along with the fuse test, and I'm getting like real small readings. I mean, really small voltage, millivolt readings, and then I hit that, and it went up quite significantly. So we pulled that fuse out, and everything went away. So we were like, cool, that's it. Something wrong with that BCM. It turned out to be the ground where it went to the seat. It was really corroded, so underneath the seat. 562 is the next code. System voltage low, system voltage high. This could be caused by a bad ground wire because the regulator has to ground and they're able to control the voltage, or it could be caused by a faulty voltage regulator or alternator. Let's talk about these two. I'm going to tell you why these come on, the two communication lines, and then we'll talk about the diagnostics of it. But we'll go a little bit more depth on these two because these are the ones you're going to see a lot more, and these are the ones that are going to be a little bit more complex to figure out. It's not so much just checking the battery volt drop on these. 621 deals with the L terminal, which is the line that comes from the PCM to the voltage regulator to turn it on. This doesn't send any kind of a signal or a very low signal until 10 seconds after it starts. Now, this code doesn't separate the two for you, so you've got to do the work yourself. But if you get this code, it's either because this PCM saw that there was high voltage on that L terminal, meaning that it's more than the small amount it should see when the key is on, engine off, because it's not even trying to tell it to do anything for 10 more seconds. So if it sees it within 5 seconds, it's got high voltage, it knows you probably got a short to power there, and it'll pop this code on. Or the L terminal has very low voltage 15 seconds after it started. 10 seconds after it started, it should start to give you voltage, but it's saying it's got low voltage. So it waits an extra 5 seconds to make sure what's going on. And if it sees low voltage, then it thinks, okay, you must have a short to ground. Something's going on there where there's not voltage going down that line. F terminal. This is your return line coming from the voltage regulator to the PCM to indicate alternator load, or the monitor line. The ECM detects a signal 65% or higher. So you've got a large signal coming back from an alternator that's not working. It's telling you that it's working its butt off and it's not doing anything. You got a short to power. Or it says it's not doing squat after it starts up 15 seconds later. It should be at least giving it 70% because of soft start. Start mode, excuse me. Because of start mode, it should be at least 70%. But it's saying it's a low percentage after it starts. So either you've got a bad wire there, a short to ground, or you've got a faulty voltage regulator that's receiving a command and not sending something back. So there's three ways to verify both the L and the F terminals. We can do this through voltage, we can do it through duty cycle, or we can use a lab scope and do it with frequency. Now keep in mind, all three of these signals are exactly the same thing. It's just how you want to read it. This is using see, there's your 70% pulse width. which is 70% of 5 volts, is 3.5. It's not exactly 3.5 on the screen, but you get what I'm saying. 70% duty cycle, or if you want to do it by voltage, you're going to see 70% of that 5 volts. So the first way, before we get started on that, we need to figure out which wire is which. When you look at this plug-in, the wires on the L terminal are going to be red on the vehicles that are RVC, which are the cars, and brown on the SA RVCs, which are the pickup trucks. Now the F wire is always going to be gray. The difference here, in all reality, is most of these things are buried so far down you can't get to them, or some of them are. And when you do get to them, what color are the wires? Black, because they're covered with grease. So if you go to RemyAutoParts.com, type in that vehicle, and look at that schematic, it'll show you, here's your clip, which side's which. It's a lot easier way of doing that. You can go in there and figure out which one's the L terminal and which one's the F terminal, simply by that. And that RemyAutoParts.com is on the back of each one of your books too, along with the tech line. Okay, so the L terminal, what's really going on here? L terminal is the on command for the alternator. This is the wire going from the PCM out to the voltage regulator's microprocessor. Since 5-volt signal is a variable duty cycle signal at 128 hertz. So it's turning on and off 128 times a second with a 5-volt signal variable duty cycle. That duty cycle should be between 6 and 94%. If it's 0 to 5, you've got a short to ground or an open circuit. If it's 95 to 100, you've got full voltage going down that line or short to power, which is the same thing. So here's what the signal should be. When you turn the key on, engine off, you go out there with your pin and put it in the L terminal, red lead to the pin, black lead to ground. If you want to look at it with voltage, turn it to DC volts, and this is what you'll see. You turn the key on, you'll see little to no voltage there. On the 2014s and 15s and above, when they come out of warranty here pretty soon, right? You will see 5 volts there until it grounds it. So there'll be a momentary 5 volts, and then it'll go down just like a lamp light kind of does. As soon as the light comes on, it'll drop down to like a half a volt to a volt. But the premise here, the premise here is that you're going to see very, very low voltage because nothing's really happening yet. You start the vehicle up, and it will go to at least 3.5 volts because that's 70% duty cycle, which is what the start mode is. And 70% of 5 volts, which is our duty cycle, would be 3.5 volts. So you're going to see at least 3.5 volts. Now when you add loads, that number is going to go up. But this is real world stuff, right? We're in the shop. It's got a 621 code. What we're really going to see is when you turn the key on, engine off, that's going to be a low number. When we start it, it's a low number. We add loads, it stays a low number. Then we know we got a short to ground or an open circuit. Or we turn the key on, and that's a high number, like battery voltage. Start it up, it doesn't change, and so on. Even though the computer is showing what's going out, if there's voltage introduced into that, that's what we're going to see out there, and vice versa. If the computer's sending 70% out, it's going to show 70% because it's sending it out. If that wire's cut, guess what we're going to see on the other end of it? Goose egg. So keep that in mind, that when it comes to the shop, that's what it's supposed to do. What you're going to see may differ from that because there is an issue. If it stays low, short to ground. If it stays high, you got a short to power. If it's 0, you probably got a cut line. And you always want to check everything else before condemning the PCM, because we rarely ever see the PCM be the problem on these. Check the wiring harness all the way out and in. Have you guys experienced one with a bad PCM, RVC system? No? Okay, I didn't know. But here's my preferred method, and let me explain why. You turn your DVOM to duty cycle. You put your scan tool in there because the scan tool, when you go to the parameter identification or the PID for charging systems under data stream, what do you see when you're looking at the screen? duty cycle. It says duty cycle. It'll tell you what it's telling the alternator. It's not going to tell you voltage or anything else. It's going to tell you duty cycle. So this is on duty cycle, key on, engine off. You've got 0. It says 0. Cool. Start the car up. 10 seconds later, it goes to 70%. Wow, scan tool says 70%. So you can mirror it directly with the scan tool and see if you're losing anything also. And that's why I like to do it with the duty cycle. Now, again, if you're shorted, if you're open, you're going to see zeros all the way down, regardless of what the car is doing. And if you're shorted to ground, these are going to be really low numbers all the way down. And if you're shorted to power, they're going to be super high numbers. If you're shorted straight to battery, it's going to be 100% all the way down, no matter what you do. So with the scope, this is how it's going to look. Key on, engine off, you're going to be basically flatlining. Unless it's a newer ones, then it'll just stay up here for a minute and go down here. Key on, engine running. You're going to see about a 70% pulse width, which is that top part of that duty cycle. And then add loads, that pulse width will increase. So F terminal, this is the return line. What's going on with this one? This is the alternator reporting back to the PCM what it's doing. This should be between 6 and 94% as well. 0 to 5, you're either shorted to ground or you're open circuit. 95 and above, you're shorted to power. Same as the other one. And we'll look at that through the voltage. Voltage, key on, engine off, you are going to see a voltage reading here because this is a 12 volts return line for 100 hertz. It will never, there's no algorithm that says L's doing this, so F should be this. It doesn't happen that way on this. This is just a communication separate from the other one. L terminal is saying, turn it on, give me this. F terminal is saying, this is what I'm giving you. 12 volt signal, it's about 30-something% when it's turned on, so you're going to see a voltage there. The key is as you start that, that voltage will go up. As you add loads, that voltage will increase even further. If you have a F terminal code, in some cases, that'll stay 0. And you're going, okay, it's 0 all the way down. This is at the regulator that we're plugging it in. If we're at the regulator and we're back probing it and it says 0 all the way down, we either have a bad pigtail or we have a bad regulator. If it's getting the command and nothing's coming back out, and we've got B+ and a good ground on that alternator, it's probably the regulator. If it stays high the whole way, we could have a short to power. Because if power is shorted up here, it's still going to show up down there by the pigtail. So keep that in mind. Here's what it looks like with the duty cycle. This will mirror what the scan tool's doing. Again, you'll get a duty cycle reading. The number will go up as you start it, 10 seconds later, right? And as you add loads, it'll go up even further. If it stays high, you're shorted to power. If it stays low, you could have a bad pigtail or a bad regulator, because that's right where we're at checking it. If you've got a signal that's perfect coming out of there on the F terminal, and you've got that code, and you're looking at your scan tool, and it says nothing's making it back, somewhere past that pigtail is broken coming up to that. So you'll need to follow that wire and go to the connector at the actual PCM. But I got a better way to show you on that. Let's talk about this real quick first though. Scope, you're going to see a duty cycle or a pulse width, and it'll increase as you start it, and it will increase even further as you add loads. You see where these are all the same reading, they're just different ways of reading it. So let's turn the car off and let's unplug that thing. Now I've got that pigtail unplugged from the alternator. I can send it a signal all day long on that L terminal. It's still going to go down to that pigtail. But what's going to come back to the PCM? Nothing. So if I'm looking at my scan tool, plugged into the data port, I unplug that, I turn the key on, I start it up, I wait 10 seconds. I should see 0 on data stream as a percentage of coming back on the F terminal, because there's no way it can give me anything because it's unplugged. Okay. Now, the true shot on this should say 70% because I started the vehicle up. It would go to 70%. It's still sending it down there, but it's not coming back. And the key to that is that a lot of times you'll get a 621 and a 622 in conjunction with each other. because even though the computer's sending a signal out, it's getting nothing back. So it doesn't know if that wire is broken and not making it to the regulator, or if it's just not coming back because the regulator or the wire coming back. So just keep in mind it's a complete deal there. If you get, you'll probably get both of them together, then you'll know that the computer didn't receive a signal, so it didn't know if it ever made it out there. We're going to do something even better on the F terminal. On the F terminal, okay, so we unplugged it and it went to 0. What if we saw a voltage there? If we saw a duty cycle signal there, what would the case be? I got it unplugged. I shouldn't see anything. Short to power, absolutely. So if I see a number there, I'm shorted to power. Well, let's check for short to ground. I'm going to take my test light, I'm going to back probe the F terminal, and I'm going to take that straight to the B+ post. So I'm sending straight power down through that test light. If I get a short to ground, what's going to happen? If that F wire, unplugged, is shorted somewhere to ground, what will happen to that test light? It will light up. Because that power will go through this bulb, through that wire, to wherever it's grounded, and it doesn't want to be grounded, and it'll light up. If it doesn't light up, what should I see on my scan tool? 100%. Because I'm sending pure voltage down there, just like that guy cranking that throttle all the way open. 100%. Pretty easy way to test that, isn't it? That light bulb pops on, though, you got to go find the ground. Or if you open it up, or if you get 0 here, if you put that in there and you get 0 there, what do you got to go look for? Open wire. Pretty easy to diagnose. L terminal, I turn that key on, back probe that L terminal at the alternator, and I compare what the scan tool says is going out as to what I'm getting out there, whether it's in voltage, duty cycle, or a scan, lab scope, excuse me. If I'm doing it in voltage, I have to take that 5 volts times my duty cycle to figure out what I should see out there. Simple enough. On the F terminal, same thing. I can go out there and see what's coming out of it. It doesn't tell me what's making the computer, so I unplug it and I send things through it. I unplug it to look for 0. If I got voltage there, then I got a short to power. I add voltage to it. If the light bulb lights up, I got a short to ground. If there's 0 on the scan tool, I got an open circuit. So that's pretty easy to diagnose there too. But once we're done with all our corrective measures and we've fixed every circuit that we've found that's a problem, we've tested our battery, whatever the case may be, replaced the battery current sensor, whatever was the case with the vehicle, we still want to go back, test drive it for a little while, make sure that light stays off, and we want to check it for voltage and amperage to make sure everything's working correctly. So to put it together, making sure that you understand that the L terminal is the on command. That's what turns on the alternator. That is the PCM's commanded output of the voltage. It also allows, that line also allows for diagnostic monitoring. If there's an issue with that line, you're going to get a code. PCM's watching it. F terminal provides an output signal from that voltage regulator back to the PCM to indicate alternator load. It is also monitored and it allows for diagnostic monitoring. We can actually physically check it by doing those tests I showed you. So with that said, to sum it up, we want to visually check all of our connections, test our battery for state of charge and capacitance. We want to verify the belt condition, check our automatic tensioners and our pulleys, retrieve any codes and diagnose them accordingly. We check that light bulb on the dash, make sure it lights up. Pretty simple stuff. Make sure you got B+ at the back of the alternator. Do any voltage drop testing that you need to do. Repair circuits or replace any of the components accordingly through our diagnostic procedures. And then go back and retest the alternator for output and for voltage. So current and voltage. Well, keep this in mind. If you come up with a question or think about something later that you're like, I didn't get that answered, or I remember he said this and I forgot what that was, you can call this 800 number at any time, Monday through Friday, and they will help you out. I think they're open until 7 o'clock p.m. Central Time. Again, guys, thanks so much for coming out. Appreciate you. Hopefully you'll come out for the next one we come by, because we have Ford, Hyundai, and Honda, and some other ones. So.